Yeah, hi. Okay, so we have planned to discuss this mock today. We have released today this mock paper. Let me share my screen. Okay. So I hope you received the announcement regarding this mock we have released. Yes, I think today or morning. So that is one mock paper. This is for present. Hmm. Okay, so this paper we have released, and we supposed to you to submit before 21. Okay, uh, till night. So because that is also considered as a some bonus marks. So all mocks are actually considered as a for the bonus marks. So complete it, and so today's session we will also discuss these questions. So this is basically is a last term and term QP. Okay, so last term we use this these questions in the end term exam. So you will also get an idea that what type of questions will come. So I hope am I audible now? Okay,
Yes, sir.
okay, fine. Okay, so basically the syllabus for the end term is all week. Okay, so not only the week 9 to week 12. So this time all weeks will be covered. Okay, approx equal weightage. And you have already given the quiz 1 and quiz 2, so you have good idea from week 1 to week 8 of the questions. So we will recap all these questions in this mock paper today, and you can also just solve with me here. Okay, so we will discuss each question, and you can also tell me your answer, what you think. Okay, so any query before starting this? Anyone?
So the weightage is same for like every week.
Approx equal weightage from week 1 to week 12. And
Okay.
maybe last week have less weightage. So that is a generally theoretical week. So maybe one or two question only.
Okay, sir. So total how many questions?
Approx 20 to 25 in between.
Okay, sir.
Okay. Yeah.
Sir, do we get programming questions?
No, maybe one two question maybe based on some that concept which we have learned, and that type of question is also there in your assignments. No programming writing based questions.
Okay, sir.
Okay, so pattern of the questions will be the similar of quiz one and quiz two, but maybe some this script type of questions may be there. Okay, not too much. Only one two question. Okay, so okay, any other? Okay, then let's start then. So first question is so I'll ask the answer from you, so your side. So what do you think for the this question, and then we will discuss. So which of the following is a reason for designing a microcontroller instead of using a microprocessor? Yeah, so the first option, to achieve higher computational power, to minimize power consumption and extend battery, and to accommodate large on chip memory capacity, to simplify the design for general purpose computing task. So which
D,
option
sir.
you which one?
D, option D.
Option D you think?
Yeah.
You say which of the following is a reason for it designing a microcontroller instead of using uh, general purpose computing task? Do you think we used microcontroller for general purpose computing tasks?
I think I forgot. I think so, sir.
General purpose like device our computer which can perform multiple tasks and a normal general purpose computing task. So
Oh,
microcontroller is
mm,
not designed for that type of task.
yes.
Hmm. Yeah, so to achieve higher computational power, so do you think that microcontroller have the higher computational power?
No.
This is also not the case. Okay. To accommodate a larger on chip memory capacity. So, the microcontroller contains the large memory.
No, sir. Answer should be B.
So, there is a one option to minimize power consumption and extend battery life. This is
Yes.
the actually main purpose of the microcontroller. We used this. So, because we have the limited resource, limited power, limited memory, and limited that uh, processor also. So that things we want to perform our task for the long term with the minimum power consumption. So our battery life will maybe extended due to the minimum power. So that is the one main goal for the microcontroller. So for this option, B is the correct answer.
Okay.
Second, this is basically memory based. If you can recall from week 1 and week 2 content. So, which instruction set architecture ISA is primarily associated with the Arduino platform? So, here you have to recall the content of the week 2. These are the discussed things. So, I'm telling you the answer for this. This is AVR basically. So mostly Arduino platform are primarily associated with the AVR instruction set architecture. Okay, so you can
Okay.
keep this in your mind. Okay, next move to the question number 3. Which of the following mask would you use to check the sixth indexed bit from the right of a byte Z to set to 1? Consider zero based indexing from right to left. Okay, so this is about the bit operators. So we want to set the sixth bit indexed bit from the right to 1. So what mask we can use for this operation? So I hope you can remember this topic. So this is the bitwise operator in task. So to set any bit, suppose we have like this bit. Suppose we have a value like 1010. This is just a we have a one bit binary number, and we want to set sorry this bit, okay, 0 bit, not this 0 bit as a 1. So to set any particular bit, what should be the mask for that? So that means to set particular bit, we have to use AND operator. Okay. So but with AND operator, what value we should take corresponding for this?
100.
1 second. So which of the following masks would you check if okay? So we are checking, not setting. We are checking that sixth index bit from the right is high or not.
Okay.
Okay, so for checking, actually, we will use AND operator. And what should be the mask for that? So that we will decide. So how actually AND operator will check the bit? Because suppose if we set AND operator and we take consider that what are the bits set for this. So we suppose if we take 1110. Okay, so, okay, suppose we are checking the third bit. It is set or not. So let me just remove this. Again, I'm writing. Suppose 1010. Okay, so this is zeroth bit, this is first, this is second, this is third. So here we are just checking the second bit is high or no, low. So let's just make the mask like this. So 100. So corresponding bit which we are checking, just keep that as a 1. Other bits just set as a 0, and just perform the AND operation with this. So AND operation said that if both bit is high, then output will be high, otherwise 0. Okay. So in this case, if you are getting like this, so usual 000 10, because here 10 is there, so this will also become 0. Here 010, this is
0.
100. So if you are getting all 0 answer, okay, so all 0 means this total will become zero value, equivalent to 0 decimal value. So if you are getting 0, that means your corresponding bit is not set, low. If you are not getting 0, then this bit is set, high. Okay, so this is the way to check any particular bit, how we can identify that any particular bit is high or low. So we perform the AND operation with the corresponding bit is high, other are 0. This become a mask for that. Okay, so now the question is very similar to this. So now we have this, we are checking sixth bit. Okay, sixth bit. So 6 means 0, 1, 2, 3, 4, 5, 6. Okay, because it is mentioned that consider 0 based indexing. So we will start the index from 0, from the right. Okay, then we are checking this bit, and we are checking this bit, sixth, from the right. Then what should be the mask for this? Mask for this is so sixth index bit from the right, from Z is set to 1. Consider 0 based indexing from the right to left. Okay, so this bit should be 1, remaining should be 0. Okay, so then we will get the answer. If you are getting 0 answer, then that means this bit is 0. Otherwise, if you are not getting 0, you are getting other than 0 value, so that means this bit is high. So if this bit is high, then you will get a corresponding 1 here, and remaining value will be 0. So overall decimal value will become other than 0 value. So we can identify that if we put this mask for the AND operation with the corresponding number. So now what is this value in the decimal or hexadecimal? Sorry. Okay. So hexadecimal, this value is equivalent to, so this is 1000000. So because this option is given in the hexadecimal form, so we will take 4 bits first, then remaining. Okay, so if we have only 3, we will put one more 0 before this. So what is the corresponding hex value for this is 0, and corresponding hex value for this is 4. Okay, so this is equivalent to 4. 100. So this is 40 is the hexadecimal. This is 16 base. So this should be the mask. So this is the correct option. I hope you got the concept behind this, how we are checking.
Yes, sir. Understood.
Okay, so this is the correct answer for this option. Okay, let's remove this. Putting this. Okay, so next is, which of the following data types would be most memory efficient for storing the small integer number in an array, given that the maximum value of numbers can be 700? Okay, so here some range is given, and you need to identify that which data type we should use. Yeah,
Should it be C?
C. Okay, so you mentioned that C. Uh, can you think about this statement? Value of number can be 700. So this option C has the 8 byte. What range it can store maximum? 2 to the power 8. Okay, so uninteger means unsigned integer. So unsigned integer means we can take
Positive one.
256 value maximum,
Yeah. Okay.
0 to 255.
Oh.
So these number of value total 256 element value we can store, but the range will be this. So this 700 is not coming in this range.
You and 16.
So this integer is the so we are looking for the small integer number. Okay, so this is the 4 byte. This is also a 4 byte. and this is 8-bit or this is 16-bit, means 2 byte. Okay, so here to save this value 700, we need at least this one. Okay, 16. Okay. So dictate. So this is the correct answer for this. And next is this. Okay, so here we have this. A CPU has 128 KB, okay, of SRAM connected to its starting address. This one. What is the address of the last byte in SRAM? So we have total this 128 KB. Okay, this is the size of SRAM, but the which is starting from this address in our microcontroller. So you know that in the microcontroller we have memory, and that memory is separated into some different parts, SRAM or this some another cache memory or many things. So many type of memories are there. So that memory is separated by from some address to some address like this. So here this is the base address given, and this is the size of SRAM. So what will be the last address? Last byte address. So how we will calculate this? So for this, what we will do? We will calculate the calculation. So we have total 128 KB. Okay, so KB is there, and these address are given as a that byte address. So we will add one, so we will get a 1 byte. Okay. So to find out the all address in bytes, so what we will do, we will just multiply by this. So in 1 KB, we represent it as a 1024 bytes. 1 KB is 1024 bytes. So 128 KB now become a total. This will become a, let's open the calculator. So calculator I think is allowed in the okay, so 128 into and 1024. So this is the value 131072. Okay, so this is the bytes, and so this is the starting address. Now add these bytes into this starting address, but we cannot add directly like this, so we have to identify the hex equivalent of this. Okay, so but because we want to add this, so this is asking the last byte address. So this is the overall size, so we will reduce one from this, so that will become 131072 minus 1. Okay, so last byte for the last byte address, so this will become a 131072 minus 1. This is now 1. Okay, so now this is the address, and we will convert this address into a hexadecimal form. Okay, so this is like a decimal value, and what is the equivalent of this in the in number? So decimal. One thing you can do, you can just convert this into a hexadecimal number, and then you can identify that. Okay, so I'm for the time saving, I'm just using binary to hex. So let's copy this, not binary, decimal. So 131072. Oh, not this, the first one. This is sorry one. So you can see what we are getting. We are getting 1FFFF. So this is the hexadecimal number. And we have this question. So 1 4 time f. So this means in this address 0 0 3 0 0 0 0, and we have the equivalent value for this is 1 f f f f. Okay, so last this digit will be changed. So if we will add in this hexadecimal number, so this will become a 0031 f f f f. Okay, after converting this, so you can see we are getting this option A for the last byte address. Okay, so let's remove this. So this is option A. And then next question is also very similar to this. So we'll see a memory map peripheral. Okay, so this is little bit different, otherwise the same line. A memory map peripheral has a register set starting from this address. So this is the address value. Each register is 16 bits byte. Okay, 16 bits means 2 byte. Okay, 2 byte. And so if there are 8 registers in the set, what is the address of the fourth registers? Okay, so here how we can calculate. So the this is the starting list. So 1 2 3 4 5 6 0 0. This is the starting address. So first register will start from this address. Okay, first register will start from this address. For second register, because each register taking 16 bits means 2 byte, so that will be added into this. So 2 byte will be added for the second. So second will become a 1 2 3 4 5 6 0 2. Okay, so that is 2 byte. Third register address will be 1 2 3 4 5 6 0 4, and the next fourth 1 2 3 4 5 6 0 6. So here you can see fourth register says address is this one 06. So this is the one, A option. So this is the register address. We can calculate like this. Okay, I hope this is clear. How we are calculating. Hello.
Yes, sir, it's clear.
Okay, let's move to the next. So here this is also correct. Okay, so next is this is different, some calculation related. So you can see a 12-bit ADC analog to digital converter is used to digitize a signal in the range from -20 to +20. Okay. Okay. What is the minimum difference between two voltages that you can measure here? Okay. Bit, 8-bit. Okay, so first thing, we will calculate the total number of levels here. So 8-bit analog to digital converter is used to digitize a signal in the range from, so this is 12-bit, okay, 12-bit ADC. So how many levels actually we can generate from this? So then we can calculate using 2 to the power 12. Okay, so we are using 12 bits. So how many different levels we can convert? We can mm, so discrete levels. How many discrete levels we can generate? So you know that if we have two binary bits, so how many value we can represent? 2 to the power 2. That is 4. Same way we can use here. So that 4 value is like this: 0 0 0 1 1 0 1 1. Okay, so this is the 4 value can be represented with the 2 bits. Similarly, if we have 12 bits, so 12 bits is 2 to the power 12. So that is actually because 2 to the power 10 is 1024, 2 to the power 11, and 2 to the power 12. Okay, so this is 2048 and 4096. Okay, so this is the final total number of distinct label we can convert. And the total input voltage is minus 10 voltage to 10 volts. Okay, so this range is actually 20 volt. So if you just see this, so minus 22 plus 20, so the difference is 20 total. Okay, so that we can calculate. So that means what is asking, what is the minimum difference approx between two voltage we can measure. So this is simple. You can divide like this. So 20 divided by 4096. Okay. So this is the voltage. This is the total number of labels. You can calculate this. So we can use calculator again. So this is a second. 20 divided by 4096. Okay, so this value is coming in the point, sorry, 0.00488. Okay, so 0.00488. Okay, so we will convert this into a millivolt. So because this value is coming in the volt, so that we will convert this into a millivolt. So we will multiply by like this 1000. So this will become a 4.88. Okay, so millivolt. That is into 10 to the power minus 3 volt. So we can see this. Okay, so 4.88 is the minimum voltage difference between two voltage we can separate by the ADC, this 12-bit ADC. Okay, so the answer for this is 4.88. Okay, so this is the approach for this. So answer for this is this one. Okay, now the question is on the same lines. So 8-bit ADC can digitize an analog value into how many distinct labels? So in the previous question we have seen this. So that is that was 2 to the power 12. Here 8-bit is there. So 2 to the power 8. So that is 256. So the answer for this is 256. Okay. Okay, now the next again the same type of question. So what is the primary advantage of Zigbee over Wi-Fi for certain embedded system application? So Zigbee. Can anyone tell me what is this Zigbee?
Not sure, sir. It's also like some Bluetooth and I think.
This is just like a protocol. Okay, so for the wireless communication. So it's the primary advantage of Zigbee over Wi-Fi in the certain embedded system application. So here actually the primary advantage. So this is also a memory based question. So you can see all these protocol discussed in the that communication week. So the main advantage for this, because you can also see the options here. So higher data transmission rate, longer range battery security feature. So the mainly the advantage for this is lower power consumption actually in the communication. So it takes lower power. So you can just see this from the content. Okay. So this is just a memory based, no calculation for this. What is the circuit? switched connection. Okay, so this is regarding the networking. So there are two types of circuit connection is there. One is connectionless and one is connection oriented. Okay, so this is networking related question. So what is circuit switched connection? So circuit switched connection means that is actually a connection oriented. So here actually if we have suppose different net nodes are connected into the network like this. Okay, so this is a network connection and we want to perform some communication from this A to B. Okay, and so what happened for this actually, first thing before the communication, one circuit is actually prepared for this. So once path will be actually uh, ready for this, so that is called as a circuit connected. Okay, and after getting the proper path, all communication will be done from this path. Okay, so this is the connection oriented, means first we will make the connection and then we will perform the communication. So that is called as a circuit switch connection. Another techniques is like a packet, actually packet transfer. So that is a connectionless. So we just pass the packets. So that means we divide our message into a different small packets. Each packets have the sender or receiver ID. So that packet actually circulate in the network. Okay, in all networks. So that packet can be travel from any path. So packet will be reached at the every node, but if id is not matched, destination id is not matched, so that packet will be passed, okay, to the another networks. So in that way all packet will be moved from the another different paths, and finally all packets will be reached at the destination. So here actually we are not providing making any connection, proper channel connection. So that is called as a connectionless. Okay, so that is the different types. So here what is circuit switched connection is, so a connection that breaks data into packets and send them independently. So this is not correct because that is the connection less techniques. A dedicated path created between two endpoints. So yes, they mentioned that path is actually created for first, then all communication happen on that path. Okay, between any two nodes. So this option is correct. A wireless connection stabilized through Wi-Fi, a protocol used for error detection. So these are not relevant for the circuit switch connections things. So here option B is the correct answer for this. Packet switch, if question is asked for the connection, packet switch connection like this, so option A will be correct. Okay, so this is the correct techniques for the packet switching. A connection that breaks data into packet and send them independently. So question 10, option B will be correct. Okay. So sorry. So next is this. How does loop unrolling optimization code execution in embedded system? Okay. So loop unrolling, if you can remember, I think week 10, this is discussed, week 10 or week 11. So how we can make efficient code execution. So that is, so loop unrolling techniques means, suppose we are running a loop for, and we have a loop like int I, which is set to 0, and that is running like I is less than equal to 100, and then I plus plus. Okay, this is loop, and here we are performing some task like any task like suppose we are performing some array based operation, so we are just traversing array, so we are incrementing each element of the array like this, so that plus equal to 1. So what we can set I, okay, plus equal, so we are just incrementing each value of the array by 1. So suppose this type of loop is running, so what happened actually, so in for this execution we are starting from I equal to 0, and every time we will enter inside the loop, and then we will uh, go to in this step I plus plus. So this is the increment step, then connection checking, and then again the same thing. Okay, so what happening, this for this 100 time this instruction will be execute, 100th time this instruction will be execute, and 100 time this condition will be checked. Okay, so all these three operations are repeating 100 times. Okay, so total 300 operation we can assume for these techniques. So unrolling, loop unrolling is the techniques where, but we can just reduce the loop iterations here. So how we can reduce, so that is for I equal to 0, and we can set I is less than equal to 100. Okay. Hmm, uh, okay, so not 100. Okay, so we can set as a like 25. Okay, let's say 25. Or 100. Okay, and so instead of I plus plus, so what we will do, we will just write it I equal to I plus 4. Okay, and inside this what we will do, we will just write like this. So ai plus ai plus equal to 1, ai plus 1. Okay, and plus equal to 1. So instead of taking one increment inside the body, we will take four increment now. So okay, so like I plus 2 plus equal to 1, ai plus 3 plus equal to 1. Okay, so in this case what will happen, so we are starting from this, we are just performing this 4 times. Okay, and we will just uh, perform this condition to directly increment it to 4 times. Okay, so this I is 0, next time is it will become a 0 plus 4 4. Okay, so in this way, these steps total will be performed 100. Okay, for each I, but this condition will be checked 25 times, and this will also check 25 times only. Okay, so you can see total how we are reducing the total steps here. Okay, so because we will increase our value by 4 every time, so in 25 times we require these steps. Okay, so that it will be reached at the breaking condition, and our all tasks will also be done. So this is called as a loop unrolling techniques. So this is the question regarding how does loop unrolling optimize code execution in embedded system. So by increasing the number of iterations, so this is not correct. This is not optimizing. By reducing the number of iteration and the overhead of the loop control. So that is the correct answer. Okay, we are reducing the number of iteration and overhead the loop control. Actually, basically this is the loop control we said. Okay, so second option is correct for this. Okay. So what is common microcontroller to manage power? Okay, power efficiency. Okay. So what is the common method microcontrollers use to manage power consumption? Okay, so power consumption is the focus here. So how we will manage the power consumption in the microcontroller? So here constantly running the maximum clock speeds, this will increase the power consumption. Increasing voltage supply to all component, so that definitely will not optimize the power. Disabling thermal management system, so this is also not much helpful. But option C, utilizing multiple power modes such as sleep, standby, shutdown. Okay, so if our device is not using, then it will enter into the sleep mode, maybe standby mode, or maybe if for the long term, then shutdown mode. So that will actually reduce the power consumption. Okay, so based on the requirement. So option C is the correct for this. Okay, so next is what are the final value of BX and CX registers after executing the following assembly code snippet? So this is assembly codes related. So here you can go through the steps. Move BX 8. Okay, so BX is just a register. So BX move 8 means 8 value is stored in the BX. CX is 12. So 12 value is moved inside this register. Subtract bx and cx. So that is actually uh, store bx equal to bx minus cx. This is the meaning of this subtract. So bx is 8 and cx is minus 12. So that is 8 minus 12. So that is actually minus 4. Move ax to 4. So ax now become 4. Add cx comma ax. So cx equal assigned to cx plus ax. So what is the cx value? We have 12. Okay, and ax value is 4. So that is actually 16. So cx we are getting. So what is asking? Bx and cx. So cx finally we are getting 16. Bx we are getting minus 4. So you can see option A is that contain this value. Okay. Option A contain this value. So next is what is the key benefits of using microcontroller architecture in the embedded system? Microkernel architecture. Okay. So here also that okay, in his graphical user interface strong isolation. Microkernel architecture simplified debugging process isolation and modularity. This is the direct answer. Okay, so that basically microcontroller architecture in embedded system focus on the minimum functionality in the kernel, such as inter-process communication, basic scheduling. Okay, so while other service like driver file system run in the user space. So that is means this approach ensure that strong isolation between the different component. Okay, so microcontroller kernel architecture basically provide this feature strong isolation between different components, and that promotes the modularity, so making system more robust, secure, and easier to update. Okay, so this is also a that features related thing, so this you can remember. Okay, so next is what type of error occurs due to asynchronous event uh, and the order in which they occur. So here, okay, so this is what type of error occurs due to asynchronous events and the order in which they occur.
Should be seen, sir. Syntax error.
So syntax error is related to the any that language syntax mismatch.
Okay.
So here this is not related to the syntax error. This is the race condition actually we got when the events are like what type of error occurs due to asynchronous events and the order in which they occur actually. So this is related to the event. Okay, not any that
Okay.
logic or anything. So this is about the race condition.
Understood.
Okay. So this is okay. Okay, so let's use the example of the finite state machine for controlling an LED with single button. The state and events will be defined as follows. So this is just a FSM machine where some state is defined, event is defined for some connection, and this is the code given for this. Okay. The question is related to this. Which of the following transition would occur if the current state is state blinking and the event blink done event occur? Okay, so that is, so which of the following transition would occur if the current state is uh, state blinking? Okay,
The
and
answer is B.
B. Okay, so
Yeah.
let's check. And the event blink done. So we will just check the code for this. So based on this information, so event blink done is the event. So that is actually event blink done. Yeah, this is event blink done. Okay, and current state is that state blinking. So once state blinking, okay, state blinking, and event is okay, this time. Okay, yeah, so this is the, you can see this is the same case will match actually. Okay, because our current state is state blinking, so that state is matched with this. Inside this, because this is the OR condition. Okay, so if event blink done means all blinking is done, so that means this part has become true. So now current state will be moved to the state off. So this is for option B. Yeah, correct. Option B. So this is simple question. You can see the code and just check which case is matched and what is the current state. So which if conditional statement is matched. So you can verify. Okay, so this is regarding some code implementation. So free task. Okay. Given the following pre-RTOS code for the Arduino project, what is it is asking? What does the function X task create do in the free RTO setup? Which is X task create. Okay, task create this. Task one, task, oh, this is one to null. Okay, so task. Okay. So, okay, more details are not given on this, but if you can remember, I think this type of question is discussed in the week 9, I think. So this basically call is used for the create a task. So I think the name is also mentioned that task create. Okay, so it start the scheduler to manage task execution. No, and it ends. So option D actually is related to this code. X task create. So task one will be created. Second one, task two will be created, and then we will start scheduler. So scheduler will basically schedule the task, which task will be actually perform. So scheduling the task. Okay, so that is the operations of the operating system, how the task actually scheduled to the CPU. So that will actually perform by this X task start scheduler. So here this is required for the task creation only. So option D is the correct for this. Okay, so next is what problem occurs when the low priority task. Okay, so this is also a operating system related question. So week 9. So what problem occurs when low priority task uh, never gets CPU time due to continuous high priority task execution? Okay, so what happening actually, because we give the priority for the each task. Okay, so some priority value high low based on this. So if we are getting high priority task at that sometimes, so actually priority is given to the higher priority task to complete first. But what happens, suppose we have T1, T1, T2 like this. So and this priority is suppose set to 1 and 2. And after that new task is coming with the higher priority. Okay, so like T3 is coming, then this priority is like high, so 4. Okay, so this task will be given to CPU or CPU. And then this is done. Now a new one more task is ready, like that is priority 5. So that will be done. So like this 6, then this will be done. And so this lower priority task will actually wait. Okay, and that are not getting uh, allocation for the CPU due to because continuously higher priority task is coming and executing. So this type of situation, so creative problems, that is called as a starvation problem. Okay, deadlock is the different situation. So this is basically related to the resource allocation. Suppose you have a process P1 and P2, where the P1 is actually requires some resource R1. Okay, R1. And so P1 actually hold this resource R1 to perform some task. And we have another task like R2, and that is held by this P2. Okay, process P2, resource R2. But to complete this process P1, R2 is also required. Okay, R2 resource is also required to complete this P1. Same things to complete P2, this R1 is also required. Okay, so we can make this diagram in the different way to make clear. So that means this resource is held by this P1 and this resource is held by P2. But to complete both resource, P1 required this R2. Okay, P2 required this R1. Okay, so now you can see P1 actually hold this R1, so P1 will not release this R1 until it will complete actually. So it is waiting to free this R2 resource, but that is held by P2. So this is looks like if you can. So in this case, never actually P1 will be complete and never P2 will be complete. Okay, because both will wait for the another resource which is held by the different process. So this is like a situation of the deadlock. Okay, so here all process will be stuck and stopped for the waiting for the resource. So that is actually deadlock. And priority concurrency is the different thing, so that is not related to the problem, so that is related to the concurrent tasking that is handled by the that's scheduler, all these things. Priority inversion is the things. So that is also related to the this priority things. So in that case, this is just a reverse of this situation. So as I mentioned that occurs when low priority task never gets CPU time due to continuously a high priority task. Okay, but yeah, this priority inversion is that that means if any resource is held by the lower priority task. Okay, but so higher priority will wait for that resource to complete it, which is held by the lower priority task. So so higher priority will not be executed actually. So because of that, this type of situation is called comes under this priority inversion. So here the answer is B, which is related to the given problem 18. Okay, so next is you are developing. Okay, so last these questions are mostly related to the last week. Okay, you are developing firmware for sensor node in a wireless sensor network. The node spends most of the time idle. Okay, waking up periodically to transmit data. What is the best optimization strategy to reduce power consumption? Okay, so this is power efficiency related. So I think with the previous question we have also seen this type of things, how we can optimize the power. So we use this mode actually. Okay, sleep mode, standby mode. If then our any part of the controller is not using, so we will enter into the some another mode. Okay, so here this is also related to this. So implement a deep sleep mode that turns off unnecessary peripheral when the node is idle. So if a task is not happening, so what are the required related components are there? So that will enter into a sleep mode, deep sleep mode, that turn off basically. So this will improve the power on that time. So that is option C. So which strategy is most effective for reducing leakage current in the embedded system? Again, the same things. Leakage current is still also the related to the same circuit things. So if any component is not used, so that means implement sleep modes for that. So that is again same thing. C. And okay, 21. You are debugging an embedded system for a wearable fitness tracker that periodically measures and records heart rate data. You need to ensure that the system timings is not affected by your debugging efforts. Which approach would you use to minimally impact for the system performance? Yeah. Debugger that support non-intrusive tracing. Okay. Okay, so I think this is BK11 content. So that is related to the okay, how we can okay, you need to ensure that system timing is not affected by your debugging effort. Okay, okay, so debugging related, this is the question. So if we want to perform some debugging things, but that should not affect the system performance. So that techniques, actually there are multiple techniques we have discussed. So this is the first thing, is the very first add printf statement to log the heart rate data at the each measure point. But this is the additional syntax or additional code part which we are adding in for the debugging. So it will take some time to perform this task. Okay, and we are just continuously repeating the all performance things, and we are adding some code to debug. So that will take some more time, and that will consume some time also. So that will affect the performance. Option A. Use a breakpoint to pause the system. So definitely this is not correct. Right before and after each measurement, inspect the data. So breaking is totally will stop the data, stop the execution. So that is also not correct. So here this option C. So tracing, yeah, employ a hardware debugger that support non-intrusive tracing for the program. Yeah, so as we have discussed, some hardware debugger we actually that provided. So that's we have discussed also in the live sessions, SWD and this type of debugger that actually not reduce the performance that uh, by the intrusive tracing. Okay, one second. Okay, so this is the different types of techniques. Actually, that is not interrupt the execution of the system which is running, but that actually keeps the data for the debugging. Okay, with that actually read the logs actually basically when the instruction are executing, and then we can debug based on that data. But this techniques actually generally not affect the execution, or we are not also adding any additional code for this. Okay, so this hardware actually this is a hardware debugger, so that is not related to the code. So that is actually not too much impact for the system performance. So option C is the more efficient here. Use LED to indicate. So that is also the things. Here some additional uh, functionality we have to add. So if we are getting any heart rate measurement is taken, so some LED will be billing. So that some code is required for this. So that it will also affect the performance. So this hardware debugger is the efficient approach to measure the debugger efficiently. So last is 22. So this is also related to the same things. You are developing a video processing application that converts video to different formats. After releasing the first version, you notice that the application takes a long time to process large video file. You decide to use the proofing tools to understand the performance issue. After proofing your application, you discover that the significant amount of time is spent on reading and writing video file to disk. What is the most effective optimization you could implement to improve the application performance? So rewrite the file operation using a different programming language. Okay, so that is also not much relevant because programming language doesn't matter too much here. Optimize the video compression algorithm to reduce processing time. So basically, if we will use the video compressing techniques, so that will take some time. So that will actually not improve the time, but that is also the one addition thing. Implement a buffering system to minimize disk IO. Okay, yeah. So buffering is the concept here which we can use. Minimize disk IO and process data in memory. Yeah. So meanwhile, if our data IO that our data is not used, okay, meanwhile we can store that into a buffer system. So consumption will be happen. Suppose consumption is happening slowly, and production is happening fast. So we use this buffering type of systems. If you can remember that, for as a example, as a printer. So suppose we can give a complete like 100-page file to the printer. Okay, but printer actually takes time to print one page. So meanwhile, all the 100 actually page will be stored into a some buffer queue. Okay, and the sequence, what sequence we have given for the printer. So the printer will perform the printing operation on the same sequence. So meanwhile, all the page actually all the requests will be stored into a buffer or queue. Okay, so once the one task is done, next task will be taken from the buffer. So this buffer things we can use to perform these things. Okay, option question number 22. And last is the process of identifying potential ethical. This is also some theoretical things. You can see the answer for in the notes. So the process for identifying potential ethical determines evaluating options, making decision, and learning from the outcomes is known as. Okay, the process of identifying potential ethical dilemmas, evaluating option, making decision, and learning from the outcome is okay. Evaluation option, making decision. Okay, so you can see the content of Big 12. I think this B option is related to this. So this is also a memory-based things, content related. So just see the each framework, which what techniques actually we using the this. So evaluating option, make decision, and learning from. So I think guided decision making. This is the techniques actually we used for this. So you can see the content of Big 12s for this. Okay, so all these are the questions for the mock. So complete this mock before the deadline. I have also discussed all the solution answer here. If you have any query, you can ask.
No, sir, no questions.
Okay, Arpit. Okay, then if no query, we can I think close the session. So
Okay,
yeah,
sir.
thanks,
Thank you.
thanks everyone. Yeah, bye. Yeah, thanks.